Stage 1. Stage 1's lit.
It's 17 years since Andy Green drove thrust SSC to supersonic speeds of 763 miles an hour, and now the same team, headed by Richard Noble, are back to break 1,000 miles an hour.
Well, the car's well into build at the moment. We're aiming to roll it out in summer 2015, take it down to Newquay and put it down the runway there, do low speed testing up to about 200 miles an hour. All that goes to plan, then we'll take it out to South Africa and start high speed testing late summer 2015. We'd like to get supersonic, we'd like to get 800 miles an hour. Then the desert where we're running floods every winter, so we'll come back to the UK, study the data, find out what worked, what didn't work, and then we'll go again in 2016 to crack 1,000 miles an hour. And the whole idea of this project is we chose a number that was miles out there, because what we want to do is get kids interested in science, technology and engineering. We've all got the bug. We all, we like fast cars, we like our technology, we like our smartphones. What we need is more kids coming through and studying those subjects. So we chose an aspirational number that hopefully will get a lot of people excited, our engineers included.
One of the big issues when travelling at 1,000 miles an hour is safety, and the team have worked long and hard to make sure nothing can go wrong.
It's had about 30 years of man-years of cutting-edge research done into the aerodynamics. So it's all been done with computational fluid dynamics. So they mathematically map the airflow over the car, so you know where it's getting pushed out of the way. That helps you find the perfect shape, or an optimum shape. You've got small winglets at the front here, great big tail fin at the back to keep it dead straight, keep it smooth, so it just skims along the ground. You want it to be aerodynamically neutral. We're using an awful lot of things from motorsport and aerospace engineering. So the front third is carbon fibre, same as you'd find in an F1 car. You've got the safety cell for the driver. Should the worst ever happen, he's tucked inside and safe there. It's the safest place to be. The back section is aerospace grade, aluminium, titanium skin, the same as you'd find on jumbo jets.
Back in '97, it was two jet engines that took thrust SSC through the sound barrier. But this time, it's all about rocket science as Bloodhound SSC heads for 1,000 miles an hour and beyond.
Drag, which is the big penalty on a car once you're going faster than 200-300 miles an hour. Drag is very difficult. You're sort of literally punching through the air. Drag goes up with the cube of speed. So if you want to go twice as fast, you want to go a bit more, you've got to put in an awful lot more power. So that's why with thrust SSC we're using two jet engines. That was just enough to get you faster than the speed of sound. With this we're using a jet engine from a Eurofighter Typhoon, and then we're using a cluster of smaller rockets which are coming from a provider in Norway called Nammo. So the jet engine will get you rolling up to about 350 miles an hour, and then the smaller rockets kick in and take you up into 1,000. The driver very much goes out and drives a run profile. So he goes out and does a 400 mile an hour run, then a 500 mile an hour run, then a 600 mile an hour run, and builds up steadily, and they check the data at every step of the way. The camera's going to be covered in sensors and cameras, so the whole idea throughout the run, we're going to be able to stream data and video straight back to the public on the web, so you'll be able to sit at home on your laptop and watch you do 1,000 miles an hour.
The thought of 1,000 miles an hour is just frightening. Surely faster speeds are unthinkable, never mind unobtainable.
Well, this is where we think the limit of the current limit of the technology lies at 1,000 miles an hour. Where next, if we've managed to inspire the next generation of engineers and scientists, they can take it on further. They can develop the technology to push on further. They can build faster racing cars. They can build better wind turbines, more efficient solar panels.
In just over 2 years' time, there could be a new land speed record of over 1,000 miles an hour, which is 33% faster than last time, the largest ever margin increase. It's a mind-boggling speed that could stand for an awfully long time.
330, stage 2.